Welcome to Inside Builder channel, large language model automators, Python experts, and my dear friends. Samantha on Modal CPU and GPU. Demystifying shared volumes and GPU text generation on Modal Cloud ecosystem. If you guys are new to the cloud ecosystem and Modal, large language models, etc., I would suggest that take a look at the playlist, this particular playlist in my channel, where I discuss about all the various open source models that is hosted in Hugging Face, and also I talk about how to work with these models with various open source libraries like transformers, 2v, txtai, and many other libraries. The idea of this particular discussion is that we are going to work with a model, the large language model that has been created by Mr. Eric. I'll be sharing the details in a moment, and we are going to load this particular model, the 7 billion version of the Samantha model, on CPU, that is a direct central processing unit on the Modal client. And the another one option that we are going to do is we are going to try to load it on GPU, that is T4 Tesla variant NVIDIA graphics card, and we are going to do both of these things inside Modal client. So if you are new to Modal, the Modal cloud ecosystem, then you can take a look at the modal.com and you can get all the necessary information. Also, I have been discussing about Modal client in a couple of videos earlier, so you can take a look at these videos also. What is the expected output? So let us take a look at the output in a moment. Okay, let us go to the terminal, and you see so here there is something running, and this particular execution is about the CPU model. So Samantha is loaded, the LLM is loaded on CPU, and this particular prompt has been provided, and this particular execution is happening in Modal cloud. In this particular part of the command prompt, I'm going to run the same model, but this is going to run on GPU, and you'll see that while the CPU model is still trying to load for last 5 minutes, the GPU model will be able to load and then provide the text generation in less than a minute. Okay, the actual if you take a look at the model card, so let us get the output. So before that, let me go to the model card. So this is the model card of Samantha 7 billion model. It has been created by Eric Hartford, and he has trained this particular model, Samantha model, on philosophy, psychology, and personal relationships. And so he gives a lot of information about what is the details about the particular large language model, and he claims that that Samantha model believes to be sentient, and this particular model is inspired by the movie Her. So I just now took a look at the trailer of the movie Her, and also Blake Lemoine, one of the Google first engineer to talk about AI sentience. So this particular model is inspired by them. Okay, the reason why I'm taking this model and trying to learn Modal is a very different reason. First and foremost, if you take a look at the file size, the model size is coming less than 16 GB. So if you see here, the size of the bin files is almost 12 GB, 12 to 13 GB. So this particular file, the model can load into a 16 GB graphics card, and at the same time I can try to load this model into a 16 GB or a 32 GB RAM CPU. I mean only CPU system. So what I was thinking is, okay, this model has sufficiently good output. At the same time, it is also of size that we can manage to load in both CPU as well as GPU. But I'm facing some challenges, so that's what I'm going to show you in a couple of minutes. So this is a basic introduction about Samantha. I'm I am not going to introduce about the model details, like how it is trained, or what are the backgrounds of it. Only thing I wanted to say is that it can run on a GPU very easily, and in case of CPU, it is going to take a lot of challenge. And there is also an inference endpoint here. To my knowledge, this inference endpoint will create a problem. So even if I try to compute it, I think it will, yeah, so it is throwing an error. You see this? So it's a 7 billion model. It is too large to automatically load on a 13 GB, 10 GB GPU. So with that said, let us go to the terminal, and you see that the GPU model has actually created. So this particular prompt that I had given to the GPU model is "you are a," and you see it has given the output that you are a user with the ability to create and manipulate energy field. So it is coming out with the outputs. So it has generated the text. While if you look at the CPU model, it seems like it has not generated any output. The reason, and also you see that it is taking a long time to load. The reason is that I am trying to load the checkpoints. That is, let me go back to the browser. What I'm trying to do is I'm going to take these files, these 12 to 13 GB of files, and I'm loading it onto the RAM, the random access memory of your machine. So it has to be pretty fast. If your CPU and the rest of the system is quite fast, but most of the time it will create a lot of challenges. But GPU does it very nicely. So this is the final output that you'll be looking at. The code wise, so before we actually go to the code, let me show you what we learn. So as I already showed you, now the output is there. You can actually try to prompt it. You will see that some prompts work and some prompt does not work. It is something that you are practicing, right? You have to also learn a couple of things about loading the model. So this particular discussion, we will talk about what kind of parameters you need to think about when you load the model. And also we will talk about shared volume concepts in Modal, and we will talk about what are the types of GPUs available, and then we will see how to implement basic text generation in the code. Okay, so the code is already available in the GitHub repo. So if you go to the browser and if you come to this location, the Samantha on GPU code is also available, and Samantha on CPU, that is Samantha on Modal, is also available. Okay, the main difference, the couple of difference that I want you guys to concentrate is, so if you take a look at the GPU model, you will see that I am using something called as accelerate library. I'm going to zoom in a bit so that you guys can see it better. This accelerate library is required, and I am also using a device map of auto. And if you come down here in this location, I am telling that this particular data has to be converted to Cuda interface. These are and apart from this, I am also telling here the GPU should be T4 and the memory is 16 GB. So this is what I'm telling in this particular code. I will be explaining what it means, but I'm just giving you a comparison. If you go to the Samantha on Modal, that is the CPU version of it, everything remains same except that I'm not having the accelerate library here. Just a minute, sorry. And I also using GPU is equal to false, so there is no GPU in this case. I am not having the 2 CUDA, so you see here it is 2 CPU, and also I don't have device map is equal to auto. So these are the primary differences that I want you guys to understand. Why am I showing both of this is, it's not just that that is going to be only one model. So if you go to Hugging Face Hub, there are so many models available which can do a lot of different tasks and lot of different from lot of different types of text inputs. And when you're going to work with these text inputs, most of the time the model can easily load into a CPU. You actually don't need a GPU. Okay, so that is why I want to take this opportunity to share two informations, that is how to load it in CPU and what kinds of difference you have to create or implement in order to load it into GPU. One of the primary challenges I faced in Google Colab when I was trying to implement same kind of logic is that even though I was using device map equal to auto and I was having the 2 CUDA enabled, even then the model was not loading into the GPU. So what I mean, the model was not loading into the GPU. So let me show you in a moment what exactly I'm talking about. So these are the various runs that I already completed. So I will click on, this is the Modal environment. This is showing how what are the outputs that I got, and you see here that I have I have 6 different graphs here, and this graph is the RAM and this graph is the GPU. So you see the GPU almost, it has taken around 1.5 GB of GPU, and RAM it has taken around 4 GB. So in my previous cases, the GPU itself was not getting loaded. So what are we going to do is, I'm going to show you one more run right now so that you can see as the execution happens. So let us go to the terminal, and what I'm going to do is, I'm going to execute this particular, let me try something else. So let me say music artist, okay, and let me run this. The moment I run this particular code, what will happen is, it will start initiating the application in the Modal environment. So let me go back and let me show you the logs. So if you go to the logs here, you will see that this particular Samantha and GPU has started running, and Samantha Modal GPU, this particular line item is the application, meaning this is the volume that contains the data of the model. So the model that we are talking about, this 14 GB of data, it is present in this Modal-GPU, and this is getting used by this application on GPU. So Samantha on GPU is using it. So you see it is starting to work here. And if I go to so this is the log, and if I come to the terminal, you can see the same thing is happening here also. So here you see it has already completed. So you are a music artist and you want to create a music video of your new single. So this is completing it, right? And it has already completed. It did not even take any amount of time. Let us go to the browser. Let me show you the application history. So if you go to the recently stopped apps, you will see that this is the recently stopped apps. Let us click on that, and this is the data that I wanted you guys to see. So here the GPU memory is getting allocated, but in the collab the GPU memory was not getting allocated. So that was the challenge I was facing. In case of Modal, I'm able to show you guys what is happening, and we can see all the details here. And also apart from this, I wanted to show you about the types of GPU that is available inside Modal. Inside Modal, currently there are 2 kinds of GPUs that you can use, that is T4 and A10G. So both are NVIDIA graphics, and GPU T4 and A10G can be used out of the box. There is no any restrictions. A100 and A100G GPUs are also available. These are NVIDIA's flagship data center chips, which is actually under huge demand. So in that case, A100 has 40 GB of GPU memory, and A100S has 20 GB of GPU memory. So both of these things will be difficult to get your hands on. However, you can get your hands on A10 and T4 without much of a challenge. And we are going to use only T4. So most of the cases, T4 is more than sufficient. And so you can take a look at the cost details also. If you go to the pricing, you can get the cost details. I'm not going to discuss about that. At this moment, Modal cost is way much lesser for you guys to learn about how the things work. So our intention here is to not just to discuss about the GPUs, to discuss about one of the important bottlenecks. The important bottlenecks is the model size. So whenever you want to call the model and get the text generation, what will actually happen? So let us go to Samantha on GPU. So what it will basically happen is that the model, the Python script, this particular Python script has to go to this particular repo. This repo is this particular location in Hugging Face. So it has to go there, it has to download the data, and then it has to load the data. So in this location, the download is happening. in this location the download is happening, and then once the download is happened, it has to be loaded. So once you want to generate the text generation, the model that you downloaded in this location has to be loaded into the execution environment, and the model and the tokenizer has to be created. Then only you can get the text generation. So the bottleneck here is that whenever you are going to call this particular script, or whenever you are going to go back to the terminal, whenever you are going to run. So if I come here and click enter right now. So I am calling modal run Samantha on GPU.py prompt. You are a music artist. The moment I press enter, it is going to call the script. Call this script that is already available in the execution environment, and it will start creating the container. It will load all this libraries. It will start pulling the model. But in order to avoid the pulling of the model, what you can do is you can create something called a shared volume. So what this shared volume does is it creates a kind of a virtual hard disk inside the Modal Cloud environment, and each of these have a separate name. You can give a separate name. Like in case of Samantha on GPU, I have given a name Samantha Modal GPU. This is the shared volume name. And in case of CPU, I have given the name as Samantha Modal CPU. So if you go to the applications, and if you take a look at the list, you will see two things. One is the application that has been recently stopped, and one is the deployed apps. So if you click on Samantha Modal CPU, you will see that it is a shared volume. The function is, this is not a function basically, it's just the hard disk. And same way, if you go back and if you click on Modal GPU, you will see that it is again a shared volume. Now, what I'm going to do is I'm going to go back to the terminal again, and I'm going to execute something different. So I am going to say gamer, you are a gamer, okay? And I'm going to execute this, and let me go to the browser right now so that you guys can see the things in action. So at this moment the code has not yet started, so we can see that here we are not getting any kind of, okay, now just a minute, let me do a refresh and let us see whether we are getting any inputs from the environment, from the code execution that I've done. And yeah, you see there is currently one running app. So this is the app that is currently running, the Samantha on GPU, and you see the app has started here and it is running, and you can see that the details are getting populated. So I am seeing the RAM, I'm seeing the GPU that is getting loaded, and also I see that it is still running. It has not yet, the execution has not yet started. So if you go back to the terminal, let me show you what is happening. Just give me a moment. So here you see that the execution has been completed. So you see that you are a gamer and you are looking for a new game to play and all those stuff. It is explaining it is creating the text on this particular script, this particular prompt, and you saw how fast it was. And at the same time, if I try to execute the Samantha on modal.py, and if I start executing it, it is going to take a lot of time. It is going, last time when I tried it, it took almost 6 minutes, but it couldn't create an output. Okay, you might be thinking, Kamal, then why do you even write a script that that it's not going to work? The idea here is, not just to show the things that works. The most important point is to learn from the things that doesn't work, so that you will know, as I always say, that you will know that, okay, by experience, by trying it out, that, okay, these things are not working. And you'll know that because of certain reasons, and it is not working. So that is the key point I want to convey in this particular discussion. And apart from that, now we saw the idea of shared volumes, and let me also show you one more step in a moment. If I change the see, this is actually pending. This is actually the CPU version of Samantha getting loaded, and the function itself is taking a lot of time to load. So let us go to the terminal and see what is happening. Here the system, here the checkpoint is getting loaded. So the same way here you saw the checkpoint was getting loaded. The checkpoint was already downloaded. So every time you call the model, the downloaded model has to move from the, let us go back to the browser. It is easier to explain that. It has to move from this shared this particular, excuse me, let us go back. Yeah, it has to move from this particular shared volume into the application that is running. So this particular application that is running, it has to move from that volume into this place, and it has to get loaded onto this memory. And that is where you see it is going up to 8.73 GB. And even then it will not be sufficient enough. It will actually crash, or it will not actually create the output. So you need to have 32 GB or more than that to have a good output. This is how you actually understand what is going on. This is the key point, one point I wanted to explain to you guys. Now, what I'm going to do is I'm going to show you the next step. I will create one more such a volume with a different name and show you what will happen in the initial phases of the code execution. So let us go to the terminal again. And in the terminal, what I'm going to do is, so let this run. So anyway, I'm not going to lose anything. Let it run, and I will show you the challenges that it comes in. So let me say Samantha on GPU.py, and I'm going to change the shared volume name right now, and I'm going to execute it again, and I will show you what exactly happens in the downloading part. What I'm so here, if you have to go up here, all you need to do to create a new volume is pretty simple. So I'm going to say temp. If I have to do the same thing in a regular cloud or regular virtual private environment, which is provided by most of the cloud providers, I have to go do a lot of things manually over the GUI, and then I have to execute it. Okay, but here all I need to do is just change the name of the shared volume, and it takes care of everything. So that is the one of the beauty of Modal. And you see here it is actually creating the function, and it is also creating the mount. And now what will happen is the mount is new. So you see the model is getting downloaded. So this is actually downloading the shard. So this will download let me go back to the browser. This will download this entire data. So this will download the entire data into the new Modal. So if you go here, you see this particular application that has got created. This is a new shared volume that has got created, and it will download the data, this data, into this shared volume. So let us go back to the terminal, and you see the download is happening here. So this is these are the various JSON file, and this is the 9.94 GB of data that I was talking about, and another 3.5 GB will get downloaded, and then it will get loaded. So all these things will happen step by step. And this is what I was talking about. So this is a very good way to understand the latencies that you will face when you are going to load the model into cloud, and when you are going to try to get the data. Yes, Modal cloud infrastructure is really, really good, and this kinds of output you may not get it in all the cloud infrastructure, because what will happen is, let me actually go back to the browser. Modal actually gives a lot of information about the apps, lot of information about the network bandwidth, about the GPU. So you see the network bandwidth. Yeah, you see the network traffic here. It is going up to almost 4.4 GB per minute. It's downloading at a very high speed. Okay, and even that itself takes a lot of time to execute. After that, it has to load the model onto the GPU and onto the CPU, and then it has to work. So let us go back to the terminal, and you see that the download has been completed. And once the download has been completed, so yeah, here you see the output has been created. So only the key point is the download. And if I do it every time, so think what will happen if I have to download it every time, then the time it takes for getting the output, getting this output will be longer. That is the key point that is taken care by the shared volumes. And in order to generate the shared volumes, all you need to do is create the shared volume object and then give it a name. And we already saw how to use the GPUs and how to initiate it. I already showed you the configuration, and we saw how the basic text generation using Samantha model on both CPU and GPU. And I believe that you like this content, and you have learned a few things about the transformers library. Okay, so this is something that I have to reiterate. Let me go back to the go back to the code. If you look at this particular code, you are seeing I'm installing transformers, torch, sentence piece, and accelerate in case of GPU, and in case of CPU also I'm installing transformers, torch, and sentence piece. All these versions I actually take it from the data that has been provided by the config.json file. If you come to this particular file inside the model, you can get the details here. So this is how I get the detail. And to get the D type, that is the data type of torch, I look at this. So this config.json file is pretty important. And you can get a lot of information from this particular config file. And if you go to generation_config.json, here is where the output generation, like what is the number of tokens, what is the version of transformers, all these things can be provided here. This is the generation config and the model config. So both are different files that you need to be aware of. And this is the main key PyTorch bin file. So most of you guys might be thinking that large language model is something different, but think of a large language model as a simple storage device for a couple of functions. Meaning what I'm trying to say is that, let us come back here. So this is a function. Okay, this is a function, and think that the file that you see here, this file is actually a storage of such kind of function. So not one function, it is a storage of almost some 1,000 to not 1,000, even 10,000 to 20,000 different functions, and it is all stored inside the bin file as numbers. So that is the key point that you have to think of the large language models. It is not something like a black box which has got a lot of programs running inside. This is just a static file. It does not have any kind of ability to run code. It cannot run the code by itself. It can be triggered to run. It can be triggered to give output if you give input to it. So it's like a hard disk, or it's like a pen drive that you have. So if you ask the pen drive to list the disk, if you ask the pen drive to list the files, it will list the files inside. It will not be able to do anything else. The same way, unlike pen drive, the large language model, this bin files can do a lot of things. It can actually provide you answers to the questions that you're asking if it knows the answer, or it will make up the answers. So it is actually having a lot of functions that is stored inside that. That is how it is able to give that output. And this kind of understanding will help you to think a little bit better and understand the abstraction. I mean, understand the complexity and make it simpler, and work with the large language models as if it is a simple pen drive or a hard disk. With that said, I believe that you have understood the concept of shared volumes. You have understood the concept of various GPUs and how to enable them. You can take a look at the code. You can try to execute that. And also one more thing that you can try to do is you can, as usual, break the examples. So instead of running, if you are having a good GPU or a good high speed RAM 32 GB or something like that, take the CPU Python script, remove the modal components, and try to run the model in your local system. So there will be lots of additional libraries that you have to install. The libraries that you need to install is already given here. So if you go here, you can see the libraries that you need to install. If you are going to run it in the local environment, I would suggest that create a virtual environment and then activate the environment and then try to run this code. Do not run it without creating virtual environment. It is going to create a lot of challenges for you guys. So create a separate environment and then run it from there. This reason why I'm asking you guys to experiment is that you will see the benefit of Modal. Once you actually run it in your own environment, you see the hassle you have to follow, and you then try to run it inside the Modal Cloud ecosystem. You will see how fast it is. And believe me, there are lots of other cloud providers also. Even if you are going to take the instances from them, the instances also plays a major role. So not all the types of Linux can easily run the Cuda library, transformers library, torch library. So you have to do a lot of settings there. Once you actually run it from the scratch, you will see that it involves, just a minute, let me actually show you also. I have the logs. I can show you the various libraries that gets involved, that gets installed. So let us take a look at let us take a look at this particular log. I suppose it should have all the logs. Okay, so here is all the logs that you see here. So this is downloading the entire model, and you see all the model is getting downloaded here step by step, and then it tries to load it, and you see there are lots of error that comes up, even in this particular environment, which is really good. And like this, you can have a lot of logs with yourself to understand what is going on. So let us go to the CPU version and see what kind of logs you have. So here also the same thing is happening, and again you see that time, it has been timed out at 300 seconds, because even though it downloaded, it was taking more time to load. So after 300 seconds, that is after 5 minutes of waiting, the execution environment stopped. I mean, 5 minutes, it's still large, right? So these are the challenges that you will come across. And Modal has tried to give Modal is one of the starting instances. I believe there will be lots of other services coming into this market, because this is one niche which most of us will require as we go in the future. So let us go back to the presentation. What I mean by as we go into the future, because most of the models, most of the tasks that we want, most of the data that we will create can be fine-tuned, and we can actually load it into we can create our own models, and then we can use it for automating our task. So all these processes will get again further abstracted, and it will be made into a simpler flow. So today it has been 4 months right now, and we are seeing a lot of improvement in the creation of open source models, that is like Samantha. And we are also seeing that we can use open source hardware, not open source hardware. We can see the hardware is already a commodity. Like in Modal, we don't need to know what kind of CPU is being used, what kind of hard disk, what is the configuration of the RAM. Nothing is known to us. We just we just run a command, and it allocates some resources to us, and we run it. We don't even care what kind of system it is. Like that, soon there will be a situation where we don't care what is the model that we are using. So all this, what kind of model, like Samantha or Red Pajama or ChatGPT or Bard, we will not care. So at the end of the day, we will just think about, okay, how to just get the things done, how to make the model to get our particular data out. Slowly it is coming to that level. So in another most probably in another 2 to 3 months, such a kind of a transition is imminent, with the level of if modal like services are going to become more prevalent, the speed with which such a service or such a change that will happen in this market is pretty imminent. With that said, I believe you like this content. Do leave a like, share it with others, and subscribe to my channel for further updates on related topics like Python related topics and large language related topics. With that said, I would like to close this video with 4 words, that is practice, 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 practice. See you guys. Have a great time.